Okay, so this is lesson 3 in the Workplace Math 10 Trigonometry unit. For this lesson, we're going to need a scientific calculator, so make sure you have one and that it's in degree mode. Let me just check my mode to make sure. Yeah, see how I have degree highlighted instead of radians? That might look different on your calculator. Okay, so far in this unit, we've been looking at the tangent ratio, TAN for short. That is this button on the calculator, but you'll notice there's two other buttons next to it, sine and cosine, or sine, SIN, and COS for short. We're going to use those two ratios today. And those ratios involve the hypotenuse, which is a side we haven't used yet in our calculations. So we're just adding to our to what we can do here when we use those other two ratios. So let's start with some just the formulas for all three ratios, and then there's a nice way we can remember it called SohCahToa. Okay, so let's start with labeling our triangle. This is the same way we've labeled before in the first two lessons. So let's say we're talking about angle A. So angle A, the way to label the sides, remember the first one I usually like to label is the one right across or opposite from A, and we call that side the opposite side. I'm going to use blue for that side today. And then we also talked about in the last lesson that the side right next to A that's not the hypotenuse is called the adjacent side. I'm going to use orange for that side today. And then the longest side in our triangle, which is always right across from the right angle, is called the hypotenuse. We've been labeling that side, but we've not been using it so far. So we're going to use it with our new ratios today. Okay, and depending on which sides you have or which sides you want to find, that's how you choose which ratio to use. So there's three ratios in total. There's the sine ratio, SIN for short. There's the cosine ratio, and there's the tan ratio. Okay, so the sine ratio is the opposite side, I'll write op for short, over the hypotenuse. So it's the blue side over the green side. Okay, I don't have actual side lengths here, so I'm just going to write the letters. So it would be BC over AC. The cosine ratio is the adjacent side. I'll write ADJ for short, over the hypotenuse. So the orange side over the green side. Or if we want to use the letters, it'd be AB over AC. So if I actually had lengths, I could write those in there. And then finally, the tangent ratio, which we've already done before, so it's just a review, is the opposite side over the adjacent side. So blue BC over orange. Or sorry, AB. There we go. Okay, so that's a lot to memorize, those three formulas, but there's a nice little saying that we can say that helps us with that, and that's called SohCahToa. So SohCahToa helps us memorize all three ratios. If you can remember SohCahToa, then you remember all three. So let me show you how it works. SohCahToa. So there's three parts to it. So is for the sine ratio. See, S stands for sine. And the next two letters tell you the formula in order. So OH, so it's opposite over hypotenuse. And then we have Ka next. That's the cosine ratio. Ka, C stands for cosine. And then the next two letters are the formula in order. A over H, adjacent over hypotenuse. And finally, we have TOA. So that's tan, T for tan. And the next two letters are the formula, opposite over adjacent. So if you can remember the word SohCahToa, then you know all three formulas. Okay, so let's practice using SohCahToa and these three ratios to calculate angles and sides. We're going to use the same process as we did in lessons 1 and 2, but we're just using the new ratios here instead of tan. All right, so let's scroll down here. Okay, perfect. So it says write all three trigonometric ratios for angle D. So here's angle D. and then calculate angle D to the nearest degree. Okay, so first thing we always do is we write our, we label our triangle. That's very important first step. So we're basing everything off of angle D here. So I always start with the opposite side. It's the side right across from the angle. I'm just going to use OPP for short, for opposite. I've been labeling that in blue, so I'm going to continue that. Then we have the side right next to the angle, that's not the hypotenuse, and that's our adjacent side. I'm going to use ADJ for short. And then we have the longest side, of course, and that's always the one right across from the right angle, hypotenuse. Okay, so let's write SohCahToa. SohCahToa. Because that's going to help us write the three ratios. If you remember the word SohCahToa, you know all three ratios. So the first one is sine. So angle D is going to be the opposite over the hypotenuse. So the opposite side is 10. The hypotenuse is 26. So the sine ratio for angle D is 10 over 26. Excuse me. Okay, let's do cosine now. So this helps us remember that it's adjacent over hypotenuse. So if I read the adjacent side, that's 24 over 26. And then finally we have tan, and that is opposite over adjacent. So tan of angle D is 10 over 24, the blue side over the orange side. Okay, so I've got all three ratios there. A ratio is just a fraction of the side lengths. And we can use any one of these to calculate the angle D. I'm going to show you all three, but I'm just going to write down one of them. So let's say I chose to use, I don't know, the cosine ratio. It doesn't really matter which one you use, but I'll just use the cosine one. The way that we calculate angle D is, remember that inverse button we used before with tan? There's another inverse button with cosine, and we can just use it to calculate the angle. So we use the inverse cosine of the ratio. And remember, your calculator has all of those angles stored inside it. So any triangle with that ratio will have this specific angle. So we're going to access the cosine inverse button. See how mine is in light blue here? So I'm going to use my second button to access it. So see how cosine -1 pops up? That means I'm using the inverse cosine. And I'm going to type 24 divided by 26. And my calculator will come up with the angle. So angle D is approximately 22.6, or about 23 degrees. Okay, I could have used either of the other two as well. I'm going to show you. So I could have used the inverse sine of 10 over 26. I just have to make sure to change the ratio and see how I get the same answer. Or I could have used the inverse tangent, 10 over 24. All three would give the same answer. So you can use any of them. If you have all three side lengths, you can use any ratio to calculate the angle. But some cases we don't have all three side lengths and we have to choose the right ratio to use. So that's the case in the next example. Okay, so let's do this example here. I'm just going to finish writing the steps. Ratios, and then 3 is calculating. Okay, so same 3 steps, pretty much every single question in this whole unit. Okay, so let's start with our labels. We're trying to calculate angle A here. So we want to label everything based off of that. So the side right across from A is the opposite side. And the side right next to A is the adjacent side. And then the longest side right across from the right angle is our hypotenuse. Okay. The two sides that I have measurements for, oops, I've used the wrong color here. Let me just erase that. Okay. Are the opposite and the hypotenuse. I don't have the measurement for the adjacent side, so I don't really want to use that side in my calculation. So let's go ahead and write the word SohCahToa to help us decide which ratio to use. So sometimes I tell students it's actually easier to figure out which ratio we don't want to use. So I don't want to use any ratios with the adjacent side because I don't have that measurement. So I don't want to use the tan ratio because it has the adjacent side in it, and I don't want to use the cosine ratio. I want to use the sine ratio here because I have both the opposite measurement, that's 12, and the hypotenuse, which is 15. So I can write my sine ratio, which is just the opposite side over the hypotenuse side, and I have both of those measurements. That's why I'm using this one. And I can go ahead and then calculate my angle using the inverse sine button. Let's see what I get. So inverse sine of 12 over 15, or 12 divided by 15, is about 53.1, so 53 degrees. It says round to the nearest degree, so there we go. So sometimes you'll have to choose the right ratio to use when you can't use all three. Okay, so that's calculating a missing angle. Now let's practice calculating a missing side. So again, same 3 steps. We want to label, write the ratio, and then calculate. Okay, so here it says calculate the length of GH. So GH, remember, is a length from G to H. So we want to calculate this side. That's my goal, okay? All right, so let's label everything based on the angle that I have. So I've got this angle here, 36 degrees. So the side directly opposite from it is GH. That's the side I want to find out. I don't have the adjacent in this question. And I don't want to find it either. So the adjacent is really no good for me. No good to me here. The hypotenuse is the longest side. I do have that length, so we're going to be taking advantage of that. Okay, so let's write down SohCahToa and see which ratio I want to use in this question. I don't want to use any ratios involving adjacent because I don't have the adjacent and I'm not asked to find it. I am asked to find the opposite and I have the hypotenuse. So I want to use the sine ratio because I want to find this and I have the hypotenuse, which is 26. So let's write the ratio down and then do our calculation. So we have sine, and this time we have the angle measurement, so I'm not just going to write I'm going to write 36 degrees. And sine is always opposite over hypotenuse, so it's GH, the thing I'm trying to find, over 26. And if you recall back to lesson 2, the way we solved questions like this is we just used a little bit of algebra to isolate the GH on the right-hand side. So we just multiplied both sides of the equation by 26. And that cancels it out on that side. And it tells us what to type into our calculator to find GH. So this is what I want to type into my calculator, 26 times sine of 36. So I don't use the inverse button this time. I'm going to clear everything off. So 26, I just type it exactly as it's shown. 26 times sine of 36, and I get about 15.28, so rounding it to the nearest tenth, about 15.3. GH is approximately 15.3, and the units are meters, because it's a length here. Okay, so label, write the ratio that's important, and then calculate. Let's do one more. You might want to pause the video here and see if you can do the last one on your own, or you can do it along with me. Same 3 steps, I'm going to write them out. Label, write the important ratio, calculate. Okay, so here I'm asked to find JK, which is this length here. It's the hypotenuse actually, it's the longest side. I'll go ahead and label it right away. So I want to find the hypotenuse in this question. And based on the angle that I have, I'm going to make all the other labels. So this is the opposite side, and this is the adjacent side, based on that angle. Okay, I do have the adjacent side length, so that's an important length here for me. So let's write down SohCahToa, and we can see which ratio we want to use. We don't want to use any ratios involving the opposite because I'm not asked to find it and I don't have that length. So I don't want to use the sine ratio because that involves the opposite side, and I don't want to use the tan ratio because that also involves the opposite side. I want to use the cosine ratio here because I have this length, it's 11, and I want to find the hypotenuse. So that's why I want to use the cosine ratio. So let's write it down. Cosine of, we do have the angle measurement, so I'm going to pop it in there. And it's always adjacent, so 11 millimeters over r. I'm just going to write 11 just so that there's less clutter. Over the hypotenuse, which we've labeled JK. Okay, so remember for this type of question where we're solving for the term in the denominator, we want to use cross multiply. So essentially we just want to switch places with JK and cosine of 68. So you do 11 divided by cosine of 68. And that's what we type into our calculator. So this is where we calculate. Now we're on step 3. So we type it in exactly as we see it. 11 divided by cosine of 68. 29.36. So it says round to the nearest tenth. So that's 6 makes it bump up to 29.4. So JK is approximately 29.4, and we're measuring in millimeters. So it's a length. I always like to do a quick check as well and make sure that seems reasonable. Although these diagrams are not drawn to scale, the hypotenuse should be the longest side. So you should definitely expect a number that's longer than 11 millimeters, which this one is. And you also want to be careful, avoid using an equal sign here because it's not exactly 29.4. We did have to round that answer. So that's why I have that little squiggly kind of equal sign there.